All right, folks, thanks for coming. Today we're gonna deal with. We will continue where we stopped last time. We deal with graphing linear equations in two variables. But before we do that, we need to talk about slope. We need to deal with the concept of slope. All right. Slope is very, very important to understand. The condition of a line or condition of a road. Look at those two trucks there. If you ever go from Colorado to Las Vegas, you see the two signs. You always see that sign on the road, right? The sign on the left shows you a truck going downhill. That sign just shows you that the slope on the road steeps downward, right? And then see the truck on the right hand side shows you the road steeps upward. So that's where you get the idea of slope. That's how they describe slope. It either steeps up or steeps down. Okay? The slope is either going up or coming down. You always have to look, when you describing slope using graph, you have to look from left to right. You remember when we did the algebra, all that BODMAS, other operation, you gotta look from left to right. The same thing with slope, you gotta always look from left to right. Now, if you're looking at the picture there, the picture of those two trucks, you can easily tell that one is going down, one is going up. But when you actually draw, if you have to draw your own graph like that, draw that. This is x, y, x. If you draw, let me see. If you draw something like this, you draw something like that, you have to always visualize this from left to right. That way you can see it. See, this is a slope going down. The one on the left, it's like you have that truck here is going down, you see? So it steeps down. Okay? And this one, the truck is going up. The truck is kind of going up something. It steeps up. Okay? So the word slope. The word slope means slant. It means a slant up or slant down, or you can say steepness. It's steepness of the line, okay? It's a slant, okay? See, this one you say is slanted. The one on the left is slant. The road slants. Let me see. Sorry about that. Oh Lord. That one. The road slants down. Okay, so that's called it slants down. If you're looking at it from left to right, you see that? That's called negative. It's negative slope. That's what it's called, negative slope. Okay. Now this one going from left to right, you see it slants up. The truck is going steep hill. Slants up. The truck is going steep hill, and it's called positive slope. Those are the terms they use: positive slope and negative slope. Okay, just keep that in mind. Okay, slanting down, looking from left to right, slanting down is negative slope. Slanting up is positive slope. Okay, slope basically means slanting up or slanting down. Okay, that's the what I call informal definition, right? But there is a better definition, what I call mathematical definition of slope. It's like this: slope is equals to rise over run. Okay, what does that mean? Okay, again, use the Cartesian coordinate to help you. Use it to help you. See, this is the horizontal axis, which is the x-axis, is the run. It's like run, okay, horizontally. And then the vertical axis is rise. It rises up. So slope is rise over run. And then formally that another way to define it is it means change in y over change in x. Okay. Sometime you see this, but I will explain it to you. It's a change in y is basically there's y2 minus y1 over x2 minus x1. Okay, so let me explain that to you. So this is x and this is y. Let's say you start here x1, okay, and you end up in x2. So the change, you're going from x1 to x2. That's why we have here. The same thing with y-axis. Let's say you start here y1 and you end here y2. So the change goes like that. You went from x1 to to y1, from y1 to y2. So the change is y2 minus y1. In physics they call it, sometimes they say you start from x0 to x1, something like that. From y0 to y1, something like that, but it's the same thing. You started somewhere. You started here. Basically, you started here, you ended here in the x-axis. In the y-axis, you started here and you ended up there. That's all. So to find the distance, the distance you moved, you subtract where you ended from where you started. That's all that is saying. It's not saying more than that. All right, note this now. Slope helps us to determine the direction a line is slanting, right? I already said that. Down or slants up. There's another, there's another thing the line can do. Let me show you. Okay. It may go like this. This is x, this is y. X, y. It may be horizontal line. In that case, there is no slope. Here, slope is equals to 0. Okay. It may be a vertical line. If it's a vertical line, slope is undefined. Slope is undefined. Well, that will come up later. I will explain it more. Think about a horizontal line, right? Imagine you're driving your car on a horizontal line. There's no slope. You're just cruising straight. You're not going up. You're not going down. Now think about driving your car. Think about driving your car in a vertical line. You can't. Your car will just crash. It will just come down and crash. You see, so their slope is not defined. There is no slope. Over here, slope is 0. Over here, it's not defined, So anyway, that's what is going on. We will first deal with how to graph a line. Graph a linear equation in 2 variables without slope. And then we also need to graph it with slope. So what I intend to do is I have a bunch of examples, about 7 examples. What I plan to do is I show you how to graph those lines, using without slope. We use what they call y-intercept and x-intercept. And then in the next video, I will graph the same set of examples using the slope of a line. Okay? Using the slope of each line to graph it. It's important to know how to do both, because you may see both anywhere in the exam or something. Okay? So that's our next plan. That's basically the plan we'll have, for this video and the next video. Okay? Yeah, let's graph Let's graph linear equations in two variables, right? Without the use of slope concept. Okay. First, we'll draw it without using the slope. And then when we're done, we'll draw the same graphs with the use of slope. That way you can understand the importance of slope. So first we'll draw some graphs. We'll have 8 graphs lined up for you. We're gonna go through, show you how you graph them, without slope, and then later on we'll graph them with slope, okay? Now, let's look at the first one. The first one is right here. The first example is right there. This is example 1. It's right there. Okay? You see, this is the graph. Is the graph of the equation. Let me see. What you're looking at there is the graph of this equation here. Let me see if I can make it a little smaller. Just give me a minute. I'll make it a little small. It's kind of too big. I hope you can see. Yeah, you can see it. But let's shrink it a little bit. It's kind of too big. We'll shrink that a little bit. See, so yeah, you can still see it. So this is good. It was too big the way I did it before, taking up all the screen. So but anyway, you see this graph here. This graph is the graph of this equation. Y is the graph of this equation here. Y is equals to 1 over 2x plus 3. See, that's the graph you're looking at there. How did I do that? Well, if you look at the graph, again, this is a linear equation in 2 variables, x and y, right? If you look at the graph carefully, you will see, the way you can draw the graph without the concept of using the concept of slope is you find the y-intercept and then you find the x-intercept, right? Those 2 intercepts are basically what you need to draw. Then after you find them, then you use a ruler. You use a ruler and draw the graph. That's all you need. How do you do that? Let me show you how you do that. Just give me a minute. See. How you do that? This is example 1. I want it to be there. How you do that is to find x-intercept and to find y-intercept. It's easy. Okay, how you do that is, let me show you. You have, this is the graph given. The graph given us right there is, the equation given to us is y equals to half x plus, is that plus 3, right? Okay. So that's the graph you're looking at, the graph of that. How did you do that? Well, you find the x-intercept. X-intercept basically means where the graph crosses the x-axis, okay? And the y-intercept. Y-intercept is where the graph crosses the y-axis, okay? So if you find those 2 intercepts, then you have 2 dots. Then you put a ruler, you draw the graph. So how do you find x-intercept? You find x-intercept by equating y equals to 0. You say let y equals to 0, okay? And then you solve. The equation will become 0 equals to x over 2. I'm just rewriting it, x over 2 plus 3, right? And then you solve. You can move things around, you see. So what you can do, basically, you say x over 2 is equals to minus 3. I hope you can see that, And then you can, multiply both sides by 2. We're trying to, isolate x by itself to find the x-intercept. Multiply both sides by 2. Yes, you get x is equals to minus 3 times 2, yeah? So x is equals to what? Minus 6. So this is x-intercept. This is where it crosses x-axis. So you do the same thing for y-intercept. You equate x equals to 0. You say let x equals to 0, right? And then you put that in the given equation. You have y is equals to 3, right? Because let me show you in case you don't see that. Because then when you say x is equals to 0, then you have half times 0, see, plus 3, and then that will be equals to 3. Okay, so y equals to 3 is the y-intercept. Okay, so then when you have the 2 points, basically the way you can write this point is 0, because x is 0, then y is 3. And then on this other side, you can say the way you write this is x is minus 6 and y is 0. You see that, right? So let's go back to graph. You see what happened? Let me see if I can make it a little. You can see it, right? The x-intercept is remember we said it's x equals to minus 6. That's right there. Because this is x-axis, this is x-axis, right? Negative x-axis, and this is negative y-axis, and this is positive y-axis. Okay, so the x-intercept is right there. That's where the graph crosses the x-axis at negative 6. X equals to negative 6, and then the y-intercept, you see right here, is at y equals to 3. That's what we got here. So you solve those. If you substitute 0 for each of them, you get this point, you get that point. Okay, basically this point here is let me see, it's minus 6, 0, because y is 0 there, and this one here is x is 0, y is 3. Okay, that's the point here. So once you get those 2 points, you put a ruler through them, and then you draw the graph. You see, you draw it like that. So that's how you draw the graph of this equation without using the slope. Eventually, we're going to draw it using the slope, okay? So this is, we finish with that one. Let's go to the second graph. I just want to show you a couple of examples. Okay, here is example 2. You can see, I want to make sure you see it clearly. Yes, you can see it clearly. So we do this the way we did the other one. We'll find the x-intercept and y-intercept. Okay, the graph represented there is this thing here is 4x plus 2y is equals to minus 10. Okay, all right, that's the graph you're looking at there. Okay, to find the intercept, y-intercept and the x-intercept, we'll find x first, intercept. Okay, y-intercept. Okay, to find x-intercept is you know, as we said before, you take you put y equals to 0. Okay, and then once you do that, you have 4x is equals to minus 10, because the y variable becomes 0, and then if you solve, you have x is equals to minus 10 over 4. Okay, that's the same thing as x equals to minus, what is that? 2 divide this, you get 2. 2 divide this, you get 5. So minus 5 over 2. Okay, so basically, the best way to do it is to put it in decimal format. That way you can see where exactly you want to put it on the graph, because if you don't do it like that, you may get confused, right? The decimal is minus 2.5. That's the decimal right there. So you'll see in a minute. Let's do the y-intercept too by setting x equals to 0, and then we'll solve for y. Y would be 2y equals to minus 10. Y then is equals to minus 10 over 2, which will be minus 5. So y is equals to minus 5, see? And x is equals to minus 2.5. Okay. So let's say, well, another way to write this is minus 2.5 and 0, right? That's the ordered pair. 0 minus 5. So we look for this point in the graph. You see, for the x, you see right there, this is minus 2.5 and 0. See right there, that point right there. Okay, and then that's where the graph crosses the x-axis. And then for the y, what we got minus 5. So right here, x0 minus 5. This is the point right here. Okay, so once you get those 2 points, you put a ruler through them and draw the graph. You will get that graph right there. All right, so let's move on. Okay, here is the third one here. The third one is notice how the graph is if you watch it from left to right, you see it slanting down, because we're gonna go through all this when we do the same graph using slope. Now the equation that represents the graph you're looking at is this equation here. It's x plus 2y equals to 4. Okay, so we'll look for, you can see the y-intercept there. The y-intercept there is actually 2. The x-intercept is 4. See right here 4, right here 2. That's where it crosses the y-axis is at 2. Where it crosses the x-axis is at 4. So we can actually write that point as 4, 0. Okay, and write this point as 0, 2. But how do you find that? Using you set the things to 0. Let's say this is x-intercept. Okay, x-intercept, you set y to 0, and then you solve, you get x is equals to 4. See, because if you put y equals to 0, y disappears. The same thing with the y-intercept. Okay, y-intercept, you put x equals to 0, and then you have 2y is equals to 4, y is equals to 2. Okay, you see it right there. See, that's what we did. So once you find those 2 points, you can write this as 4, 0. Ordered pair. This one is 0, 2. Okay, so once you find those 2 points, right here, you put them there, put that there, and you put a ruler there and draw the graph. You find that. Okay, so that's how you do that. Now I will get to that. Notice there are other points. The point on the graph is the solution to the equation. So if you would take those points and put in here, the equation will evaluate it, it will come up with a true statement. Let me give you an example of what I'm talking about before we move on to the next example. Look at the graph, choose any point. Let's say choose any point on the line, right? I'm talking about on the line, not outside the line. See, let's choose this point here. Sorry. let's choose this point here, right here. Okay. So what is that point? That point, you go to the x-axis. X is 10. X is 10. And then you go to the y-axis. Y is minus 3. Let me make it a little clearer. Okay, so that's how you do it. You choose a point, you find the y and the x coordinates. So that point there is 10 minus 3, right? See that, right? So if you take that point and put it in that equation, it will make the equation true, because that point is a solution of that equation. Any point on that line is solution to that equation. There's no way you put that point into the equation and it will evaluate to false. It will never happen. So let me show you. So the point we'll have is 10 minus 3, right? We'll put it into that equation, right? Remember, we did that before. So this is x and this is y. So if you put it into the equation, what do you get? You get 10 plus 2 times minus 3, right? And then the question is it equal to 4, right? I'm saying it must be equal to 4 because it's on the line. Any point on the line is the solution to the equation, right? And any solution you find is on that line. Remember, I made that statement in the previous video. So let's evaluate this. We'll have 10. What is that? Multiplied 2 times minus 3. It becomes minus 6. Okay, is that equals to 4? You simplify the left side. What do you get? You get 4. Obviously, 4 is equals to 4. So this is true. So you see it's true. So any point on the line, any point you choose on that line would be, and you substitute that point in the equation, it will be true. It must be true. It cannot be false. If you want, we can choose another one. Let me see. Let's choose another one. Let's say we'll choose, let's take this point here. This point right here. So how do you find it? You go to the y-axis, y equals to 5, and you go to the x-axis, x equals to minus 6. So that point is minus 6 and 5. Okay? So if you put that point in the equation, it must evaluate to true, because that point is a solution also. So let's do that. What is that? We'll find minus 6 and 5. Look at this point, minus 6 and 5. So we'll put it in that equation. What is the equation? Equation that produces the line is this equation. 2y is equals to 4, right? That is the equation that produces that line. So you put the point in there. Don't forget now, this is x and this is y. So you put it in there. The equation becomes minus 6 plus 2 times 5. And then the equation is it equal to 4, right? You simplify the left side. What do you get? Minus 6 plus 10. Is it equals to 4? Keep simplifying. What do you get? Yes, you get 4 is equals to 4. So it's true. You see that? So any point on the line is a solution to that equation. That's all that means, man. That's what that means. So let's go to our fourth example. The fourth example is that right there. I hope you can see it clearly. Okay. So the equation is this equation here. Is y. Let me see. Y equals to minus 5 over 2x plus 5. That's the equation that produced that graph, okay? Okay. So look at the graph. See the intercept here. This is this point here is x2 and y0. Look over here. This is x0, y5, right? Okay. So we can use what we normally do. We find the intercept. Once we solve it, we'll find those 2 points. Let me show you. So for x-intercept, we'll do what we normally do. We'll set y equals to 0. And then we'll solve for x. When you solve for x, that x is the x-intercept. So you get 0 is equals to minus 5 over 2x plus 5, right? So you can move things around. It becomes 5. I'm sorry. It becomes 5. When you move it over, change the sign. 2x equals to 5, okay? So you multiply by both sides by 2. Using 2, you get 5x is equals to 10. X is equals to 10 over 5, which is what? Is 2. So, sorry, x is equals to 2. That's the x-intercept, which is the same thing as 2, 0, okay? Now, let's do the same thing, y-intercept. Y-intercept, you set x to 0. X equals to 0. And then you put it in the equation, you get y is equals to 5, you see? Because once you, in case you don't see it, let me go through the process of solving it. Because you see, we'll have y equals to 5x over 2, right? Plus 5. So once you set x equals to 0, you get minus 5 over 2 times 0 plus 5. So the whole thing becomes 0, so you get 5. You get y equals to 5. This is the y-intercept. The same thing as 0. The other pair is 0, 5. See, that's what we have here. See right here, 2, other pair 2, 0, right there. Other pair 0, 5, right there. You see? So once you get those 2 points, you put a ruler through them and draw the graph. You get that graph there. Okay? So let's move on to the next one. This is number 5. Okay, you can see it clearly. Yeah, we are number 5. See, I chose it because it went through the origin. That's the reason why I chose that carefully. So what is the graph that represents that? I mean the equation that represents that, sorry. Well, the equation and the graph are the one and the same thing. If you have a graph, you can get equation from it. If you have equation, you can get graph from it. That's why I say when we get to using the slope, you'll see. Because if you look at a linear equation in 2 variables, that's it. You can put it in a form that you read that off and then you get the graph quick. But we'll get there. That's the next thing. Then let's finish this one. What is the equation that gives you this? Is this one here? Is 2x minus 3y is equals to 0. Okay? So we'll find them. Of course, there's intercept here. The y-intercept and the x-intercept. Well, let's go through the process. What is the x-intercept? X-intercept is what? You set you set y equals to 0, and then you solve 2x is equals to 0. X is equals to 0. See that? Because here is 0, 0. Okay? You do the same thing, y-intercept. You're going to get the same thing. You set x equals to 0, and then you solve, you get minus 3y is equals to 0. Y equals to 0. You see what is going on? That's why both of them, runs through the origin, okay? Now the trick here is because both of them run the intercept run through the origin. So the trick is to choose two other points, right? You choose two other points for each variable. Like you choose a point for x, choose another value for x, choose another value for y. That way you can get that way you know how to draw the graph. But how do you, which point, what do you choose? What value do you choose? Look at this. Let's solve okay, looking for x value right here, x-intercept. Let's do this. Let's say 2x minus 3y is equals to 0, right? And then you say 2x is equals to 3y, right? If you eyeball that carefully, because you know it's easier not to choose fraction, so you choose something that will not be fraction. That way, it's easier for you to put the point on the line and then draw it. Look at this carefully, because like I said, that's why I showed you the example I showed you earlier. Any point on that graph is a solution. Any point on the line of that the graph of the equation is a solution. Any point on that line, right? When you draw that line, any point on it is a solution. So if you look at this carefully, that way we don't deal with fraction. We choose any point. Let's say, because what we're solving is, we're trying to get a point, right? So if you put y equals to like 2, right? Put y equals to 2. Let me see. Y is equals to 2, right? Then what do you get? You get 2x is equals to 3 times 2, right? So it will be 2x is equals to 6. X equals to 6 over 2. So this one will work because you're dealing with whole number, you're not dealing with fraction. So what that means is the graph crosses x somewhere at 3, because what we did, we chose y equals to 2, right? And then we'll find x equals to 3. So that's this point. In fact, if you look, well, we'll see in a minute. So if we put, let me see, x3. So if you come in here, see x3 right here, you go here, see, look at that. See, y is equals to 2 right there. So this is 3, 2. So you see, so we'll do the same thing for y. So we'll put the equation in this form. It said 2x equals to 3y, right? That's what we found over here. So we'll say what point can we choose, that way we don't work with the fraction, because we're solving for y, right? So if we choose x equals to 6, for example, it will work, because then you have, if we choose x equals to 6, we will have 2 times 6 is equals to 3y, right? So that will be 12 is equals to 3y, and that will be 12 divided by 3 will give you y. Of course, that's 4. So y is equals to 4, right? So we don't want to deal with fraction. Now go to the graph. You will see, you'll find that point. Basically, this point is let's see, x6 and y4. See, right here, x6, y4. x6 right here, and then you go up. You see, you go up right there, and then y will be 4 right there. See, so this is 6, 4. It's on the graph. Any point on the graph is a solution. So we can use those 2 points to draw the graph. Once you get this point, you get that point, and of course you have 0. You put your ruler on those points, and then you draw the graph. You get that graph. You see what I'm saying? It's very simple. So but anyway, that's what is going on. Okay, so let's go to the next one. This is what? This is number 5. Let's go to number 6. Again, I chose this carefully. Notice what is going on there. This is a vertical line. So I want you to see what that means. When you have a vertical line like that, it means something. Let me show you. The equation that produced that is this equation, x minus 4, okay, is equals to 0. This is the equation that produced it. Alright? So, if we proceed as we did in the past, we'll find the x-intercept. X-intercept will be, you set y equals to 0, right? Notice something, there is no y there. There's no y in the equation because y is not there, right? You know, so basically that's why you have that. That's why you have that graph like that. Set y equals to 0. There's no y. So you say x minus 4 equals to 0. X is equals to 4. You see that, right? It's equals to 4. Sorry. Okay. That's why you see x is equals to 4. Now, let's do the same thing with y. Y-intercept. Okay. So you set x equals to 0, right? If you set x equals to 0, then you got, what do you have? You have 0 minus 4 equals to 0. And then when you simplify the left side, you get minus 4. It's not equal to 0. So that cannot happen. You see that, right? Because the graph doesn't cross y anywhere. There's no y-intercept. The graph is a line that goes perpendicular line, right? A vertical line that goes through 4. You see that, right? You know, basically once you get that, you just draw a straight line through 4. That's all you have to do. See, this one is a horizontal line. You see, I chose that carefully. The graph, the equation that represents that is y minus 5 is equals to 0, right? Now, to look for x-intercept like we normally do, x-intercept is means you set y equals to 0 and solve for x. But notice there is no x in the equation. So if you set y equals to 0, you get 0 minus 5 is equals to 0. Minus 5 is not equal to 0. So that's why there is no x-intercept, you see. And then you look for y-intercept. Y-intercept is you set x equals to 0. Again, there is no x in the equation. So you solve, you get y is equals to 5 if you solve that equation. So that's why you just draw that line through 5, because the point here is 5. That's 5 right there. Basically it's 0, 5. I'm sorry, 0, 5 right there, see? So it's y equals to 5. You draw that through there. You just put your ruler through that line and draw it, just the way you did for x equals to a number up there. X equals to what? Equals to 4. So you do the same thing. Okay, you deal with the vertical line. All right, you know. But anyway, this is all I have for you today. Please subscribe to my channel, like and share this video. If you have a comment, leave it under the video.